Hey, just for a second, take a look at the device you're on right now. It's an incredible piece of technology, right? But have you ever really stopped to think about what's going on under the hood? We are so surrounded by computers every single day that honestly, we kind of take them for granted. So in this explainer, we're going to pull back that curtain and really demystify the machine that has completely changed our world.
It sounds like a trick question, doesn't it? I mean, on one hand, you've got this sleek little device that just slides right into your pocket. On the other, you have this behemoth from the 1940s that literally filled an entire room and needed a whole team of people just to keep it running. Well, the surprising answer is they basically share the same DNA. They are both computers, and the story of how we got from one to the other is one of the most amazing stories of human invention.
You know, the computer has become a total chameleon. It's not just that beige box sitting on a desk anymore. It's the laptop you do your work on, the tablet you read on, and of course, the smartphone that's pretty much your connection to, well, everything. It's a tool that's so woven into our lives, it almost feels like a part of us. And yet, for most of us, what's actually happening inside is still a complete mystery.
All right, so to really get a feel for the power you're holding in your hand, we've got to rewind. We need to go back to the very beginning. The story of how we went from these massive, room-sized machines to these tiny, pocket-sized powerhouses is, well, it's a wild ride through the history of technology. What's so cool about this timeline is that every single leap forward was kicked off by one single revolutionary idea. We started with these huge, clunky vacuum tubes that sucked up tons of power. Then, bam, the transistor comes along and changes everything. Then the integrated circuit crammed tons of those onto a tiny chip. But the real game changer? The microprocessor. An entire computer on one little piece of silicon. And get this for scale. The smartphone in your pocket today has over 1,000,000 times more processing power than all of NASA's computers combined when they put a man on the moon. That is the kind of insane progress we're talking about. Which brings us to today, with AI and even nanotechnology, where we're building machines literally atom by atom. So, all this incredible evolution didn't just lead to one kind of computer. Not at all. Instead, it gave birth to a whole family of them, with each one designed for a very specific job. Let's take a look at the different branches of this family tree. We can pretty much split the computer world into two main camps. First, you've got your general-purpose computers. These are the versatile workhorses, like your laptop or your phone, that can do pretty much anything, from writing an email to browsing the web to playing a game. And then you have the special-purpose computers. These are the specialists, the machines built for one single, high-stakes mission, like predicting the path of a hurricane or guiding a satellite through deep space. So, for most of us, our entire digital life revolves around the microcomputer. This is the personal computer in all its forms. The desktop at the office, the laptop in your backpack, and of course, the smartphone in your pocket. They're built for one person, putting a whole universe of computing power right at our fingertips. Okay, now let's take a step up. A mini computer is kind of the unsung hero for a lot of small businesses or university departments. Think of it as the central hub, acting as a server, managing files, running websites, and handling apps for hundreds of people all at the same time. Now, let's take a giant leap to the mainframe, which people in the biz call Big Iron. These things are the titans that form the backbone of our global infrastructure. These are the systems that banks and airlines rely on to process millions of transactions perfectly, 24/7. They can handle thousands of users at once, delivering that rock-solid reliability that these critical industries absolutely have to have. And here we are, at the absolute pinnacle of computing power, this supercomputer. These machines are incredible. They're often national assets, capable of running billions, sometimes even trillions of calculations every single second. They're used to tackle humanity's biggest, most complex problems, from creating super detailed climate models to unlocking the secrets of the universe and exploring the bizarre world of quantum physics. So we've looked at the history and all the different types of computers, but what actually makes them tick? What's going on inside? Let's pop the hood and look at the two essential parts that are the heart and soul of every single computer out there. Okay, the key to understanding any computer comes down to this one simple division. You have the hardware. That's all the physical stuff you can actually see and touch, like the screen, the keyboard, the little chips inside. But here's the thing. Hardware is just a body without a brain. That's where software comes in. It's the set of instructions, the programs, the apps that you can't touch, but it's what tells the hardware what to do. They're two sides of the same coin. You can't have one without the other. Now, software itself is split into two main layers.
At the very bottom, you have the system software. A really good way to think about it is like the conductor of an orchestra. This is your operating system, like Windows or Android. It's the boss. It directs all the different hardware parts and makes sure they're all working together perfectly. It's the foundation that everything else is built on. And then sitting right on top of that foundation is the application software. These are the tools we actually use every day to get stuff done. Your web browser, your word processor, your favorite shopping app, those are all applications. They rely on the system software to talk to the hardware, letting you do everything from writing a paper to ordering a pizza. So, this incredible partnership between hardware and software has completely reshaped our world. But like any revolutionary technology, it's a bit of a double-edged sword. It offers these huge advantages, but it also brings some pretty significant challenges. I mean, just look at healthcare. The impact there has been nothing short of revolutionary. Computers are at the heart of modern medicine, from the incredibly detailed images you get from CT scans and MRIs, all the way to the supercomputers that are helping us discover new life-saving drugs faster than ever before. And the world of finance? It's been totally remade. Online banking, instant digital payments, the complex algorithms that run our entire global economy, it all runs on massive, powerful computer systems. And of course, in education, computers have opened up the world of knowledge to everyone. Online courses, huge digital libraries, and just the simple ability to look up anything in an instant have fundamentally changed how we learn and how we teach. But with all of these incredible advancements comes a major trade-off. On one side, the benefits are just undeniable. Amazing speed, the ability to do a million things at once, massive storage, incredible accuracy. But on the flip side, the downsides are just as real. Automation has led to job losses, our personal privacy is constantly at risk from data breaches and hackers, and cybercrime has become a whole new kind of threat. It's the complicated reality of the digital age we live in. And that all leads us to the future. We've seen 6 generations of just mind-blowing progress, from machines with vacuum tubes filling a room to the age of AI and nanotechnology. So what's next? As artificial intelligence keeps evolving at this explosive pace, what will the 7th generation of computers even be capable of? And how will it reshape our world in ways we can't even begin to imagine yet? That's a question that will define our future.